An electron whose mass is 9.1 10 power negative 31 kilogram, and it is traveling with a speed of 2 into 10 power 7 meter per second, undergoes a head-on collision with a hydrogen atom whose mass is 1.67 10 power negative 27 kilogram, which is initially at rest. Assuming the collision to be perfectly elastic and a motion to be along the straight line, find the velocity of the hydrogen atom. I have a long lecture on elastic collision in one dimension, and I strongly suggest you to watch that lecture before you try to solve this question, because I have derived all the relevant formulas as well as I have discussed the special cases, and there is a lot of other information which will be very helpful for you. So to solve this question, I have already put the relevant formulas here. So once again, I want to refresh the information about the elastic collision for the students who did not listen to that lecture or who don't want to listen to that lecture. So let's discuss the elastic collision briefly. So here I have two formulas. So we assume that there is an electron and then hydrogen atom, and they have certain initial velocities. So say v1, and velocity of the second particle, in our case it is actually hydrogen. So let's assume that this is mass m2, this is mass m1, the smaller one is electron and the larger one is hydrogen, and we assume that v1 is greater than v2. So in fact the hydrogen atom is at rest, so v2 is actually 0. Anyway, v1 is greater than v2 in this case, and then mass m2 will hit the mass m1 will hit mass m2 after some time. So they will collide, and if this collision is elastic, they will have certain velocities after the collision. So let's assume their velocities after the collision v1 prime and v2 prime. Of course masses are same because there will be no change in their masses. And we discussed all of this interaction in detail, and we derived the formulas that if we want to know the velocity of any body after the collision, whether it is v1 prime or it is v2 prime, we can calculate it by only giving the parameters, initial parameters, velocity v1, v2 and the relevant masses. So here are the formulas. So v1 prime and v2 prime. v1 prime is the velocity of mass m1 and v2 prime is the velocity of the mass m2 after collision. So an electron hits a hydrogen atom with certain velocity. Hydrogen atom was at rest before collision, and then we need to find the velocity of the hydrogen atom. It means we only need to find v2 prime. They didn't ask us to find the velocity of the electron or the mass m1. Even if they tell you, you can calculate it, because if you know the formula how to calculate the velocity of mass m1, or in this case velocity of the electron. So let's write the data. v1 equals 2 into 10 power 7 meter per second. This is velocity of the electron, our mass m1. Similarly, its mass m1 equals 9.1 into 10 power negative 31 kg. Similarly, velocity v2 is 0 meter per second, because they told us that the hydrogen atom was initially at rest, which means its velocity was 0. And then mass m2 is also given, mass of the hydrogen atom, it's 1.67 10 power negative 27 kilogram. And now they ask us to calculate velocity v2 prime, mean the velocity of the mass m2, or the mass m2 in our case is hydrogen atom. So we need to find v2 prime, and you know where is the relevant formula. We will just plug in the values, calculate, and you will get the final velocity of m2. They didn't ask us to find the velocity of electron or v1 prime, but even if they ask you in the exam, you can find it as well. So let me rewrite this formula. So v2 prime equals 2m1 plus m2 v1 plus m2 minus m1 v2. So now just plug in the values and you are all set. So 2 times mass m1 is here, 9.1 into 10 power negative 31 kg, and then I need to add both masses. So m1 is 9.1 into 10 power negative 31 kg plus mass m2, mass of the hydrogen atom, is given as 1.67 into 10 power negative 27 kg. And then velocity v1 is 2 into 10 power 7 meter per second, plus, then once again I need to take the difference of the masses. So m2 is 1.67 into 10 power negative 27 kg minus m1 is 9.1 into 10 power negative 31 kg, and below is the addition of these masses, so I can write it very quickly. So because on the below there is, this is addition, so if I switch the values it doesn't matter. So I can write the hydrogen mass first, 1.67 into 10 power negative 27 kg plus mass m1 is 9.1 into 10 power negative 31 kg. So just remember that here is m1, here is m2, but I written the values in reverse order. So I wrote first the mass of hydrogen atom in m2, and then I wrote the mass of m1, mean the mass of the electron. And because this is simple addition, so it doesn't matter, because we know from algebra a plus b equals b plus a. So just remember it, because don't get it confused. And then we need to multiply, then we need to calculate, we need to multiply it with velocity v2, and v2 is 0, so this whole term will be multiplied with 0. Actually I didn't need to do all of this calculation, I could just assume it as 0 and I could solve the question anyway. So if I use my calculator, v2 prime is equal to 2.2 10 power 4 meter per second. So you must be very efficient in using the calculators, and you can evaluate this whole expression with one click. and this term is of course equal to 0. So here is the answer to your question. And if they didn't ask us to calculate the velocity of electron after the collision, but if they ever ask you in the exam, you will simply use this formula to calculate it, because you already know all the variables, and v2 is of course 0, so you will only evaluate this expression.